Hello everyone. Introduction to Chapter 5. Going to talk about something called probability distributions in this chapter. I want to start you out with a little bit of vocabulary, starting with a random variable. Let's define that to be a variable whose values are determined by chance. Almost going to make it here, are determined by chance. Okay, two types of random variables. Words you've seen before, maybe you remember: discrete and continuous. Fingers crossed that you remember. Okay, so discrete variables are going to be variables where the values can be counted. Maybe you're smiling because you remember that. Discrete are things you count. Like if we were to roll a die, flip a coin. Sorry, kind of sloppy here, trying to fit it all in this little space. Counting number of students in my classroom, number of text messages you send in a day. Those sort of things are things you count. All right, now continuous, how about anything you can measure? Okay, data is measured. And yeah, we talked about that before too. Maybe you remember things that you measure. My favorite four: height, weight, time, temperature. Okay, those are all things that can be measured instead of counted. Okay, it takes on all the values on a number line if you kind of think about that. All right, so we're going to talk about discrete probability distributions, just discrete kinds. Okay, so our random variables are going to be things that we can count. Probabilities that we pick up in here can be theoretical or done by observations. Okay. So again, we are going to do a probability distribution for a discrete variable. So one that you can count. Those are the type we're going to study. All right, so let's take an example here. Let's say we're going to toss 3 coins. Okay, and X is going to be a random variable for the number of heads. Okay, well, what could happen? Well, you could toss your coins and you could come up with no heads. Okay, or 0 heads. You could get 1 head, 2 heads. You know, they always say 2 heads are better than 1, or 3 heads. Okay, joke. All right, so you could have, like, if it's no heads, we could have all tails. So tail, tail, tail. If there's only 1 head when you're tossing the 3 coins, you could do like 2 tails and then a head. You could do a tail, then a head, then a tail. Or you could have heads and then 2 tails. Okay, my 2 heads are better than 1. You could have the 2 heads and a tail, a heads, then a tail, then a heads, the tail first and then 2 heads, or you have all 3 heads. Okay, so we're just filling those in. You could make a little tree diagram to sort those out, or you could just sort of think through it on your own. Okay, so if you count over here, we have a total of 8 outcomes possible. Okay, so then if we go over here to the little table, number of heads with your random variable X and the corresponding probability. So 0 heads, there's 1 way up there out of 8. 1, 2, 3 ways to have only 1 head out of 8. 1, 2, 3 ways to have 2 heads out of 8, or 1 way to have all 3 heads. Okay, so what we've just done is we've created a probability distribution. It just looks like a little table with the outcomes and the corresponding probabilities. You would also call this a theoretical distribution because we just sort of thought through what the outcomes were. There was no experiment performed. This is the actual what it is. Okay, so you call that theoretical. Okay, so now we have two requirements for our probability distributions, okay? First of all, the sum of the probabilities of all events has to equal 1, okay? If we write that kind of fancified, we'd say the sum of the probabilities equals 1. And remember, this just says sum, okay? Second thing, the probability of each event is between 0 and 1. Okay, and we might write that a little like fancier. You could just say that 0 is less than or equal to the probability less than or equal to 1. Okay, and yes, it can be 0. Yes, it can be 1. 0 just means it's not happening. Okay, I'll just say not happening. It's like a sure thing, not going to happen. If it's a probability of 1, if you think of percents even, that's like 100%. This is a sure thing. It's going to happen. You know, you look out and think, is it the probability it's going to rain today? And you look out, it's raining. Yep, that's 100% or 1. All right, so those are our two requirements. All right, so continuing on, if you're following along with your guided notes, we're on to page 2. Little examples. In fact, if you want to pause the video now and you try these and then check them alongside me, that would be just fine. Okay, so first 4 problems. Determine if you have a probability distribution. If it is not, state why. All right, so we're basing our thoughts of yes or no on these 2 requirements. Okay, so you got to think about those as we go through. All right, so number 1, we have 1, 2, 3, 4, 5 fifths. So if you add this up, the sum of the p of x's comes out to be 5 out of 5 is 1. Okay, and we have the sum of the probabilities is 1, and the probability of each is between 0 and 1, so this one's a yes. Okay, that one's okay. All right, second one. You're correct. That's a no. Reason being, we have a negative. We have something bigger than 1, so that's going to make it fail right away. All right, so that's going to be a no. All right, next one, we have to check the sum of the probabilities. When you check those sums, you're going to notice here that this is 4/16, and then 2/16, and then 1/16, 9/16. If you add that up, sure enough, 16 out of 16, which is yes, and that one's okay. All right, next one up, if you check the sum of the p of x's, you're going to find that that sum, whoops, it didn't like that, did it? Sum is going to be greater than 1, so that's a no. Okay, and again, I'm adding these p of x's. Okay, so there's some quick examples there. Next up, we have an example of discrete or continuous. Okay, so the speed is going to be continuous. The number of colas, you're counting those, that's discrete. Time, continuous. Weight, continuous. The number of people, you're counting them, so that would be discrete. Okay. All right, one last thing. Construct a probability distribution and draw a graph. Okay. Well, the distribution part's not bad. You're just going to make a little table, x, p of x. All right, your x's are here, 0, 1, 2, 3, for the number of medical tests. And then your p of x's are just going to be the corresponding probability for each one. Okay, so we're going to have 6 out of 15, 5 out of 15, 3 out of 15, 1 out of 15. Okay, so that would qualify for the distribution itself. Okay, now the graph is nice. It's not real strenuous. Okay, we're going to have just a little XY axis here. The number of tests going to be down here on the bottom. Your X values, your probabilities going up the Y axis. So down here it says 0, 1, 2, or 3. The P of X's, I always count by whatever these fractions are. So like here, I'm going to just scale it like 1/15, 2/15, 3, 4, 5, what do we need? 6. And just scale it by the fraction. 6/15, okay? And then it's just like a little stick graph. So like at 0, I've got to go up here to 6. Okay, then we're going to drop it down to 5, and the next one's a 3, and then a 1. Okay, and this is a hospital, whatever it is, number of tests, and the P of X. And that makes a nice little graph of our distribution. And I guess that's all I have to say about that. So I wish you good luck here as we start into our 5th chapter on probability distributions. Thank you so much for watching.